like Hispanic population.
Thanks, everyone. Thank you, everyone, for being here. Really excited to see
Closer to your mouth so we can hear.
the friends, family, and all the students who are coming to see these presentations. I'm really proud to be presenting the first session from the MSDS program. So in this session, we're going to have two different talks from the Archdiocese of Seattle, and then we're going to have a talk from Puget Sound Energy. So let's give our speakers a big round of applause to welcome them.
Hello everyone, we are Team 25.2 working with Archdiocese of Seattle, working on the project understanding the demographic trends and engagement pattern within Archdiocese of Seattle, more specifically from cultural communities and young adults. In this project, we are going to show you the findings which will be used for effective pastoral planning. Let's begin. This is our team, Janani, Prasanna, Satvik, Tingu, and myself, Surya Kailash.
What is an archdiocese? This shows the organizational hierarchy of the global Catholic community, headed by the Pope, and then in the structure comes archdiocese and diocese, which are the larger geographical unit, and they have multiple deaneries under them, which are smaller geographical units, and then they are further classified into parishes, which include the structural unit along with its people who come to practice faith.
Let me give a quick overview about Archdiocese of Seattle. More than 1 million Catholics participating in faith in Western Washington. They had 174 locations, which includes mission stations and parishes. They offer faith-based education in 74 Catholic schools. They conduct 500 plus weekly masses in 11 different languages. They support 60 ministries. And they had 10 deaneries, which was their own boundary.
For the project, most of our data came from internal records provided by Archdiocese of Seattle. This including data on parish demographic, participation, finance, and geographic information. And to make the analysis more complete, we also brought in US census data to provide additional population context.
The project primarily focuses on analyzing two key areas. Firstly, the cultural communities. These are the groups based on shared ethnic, cultural, and the language backgrounds. For instance, the Vietnamese community or the Spanish community. And secondly, the young adults, especially for the individuals who are aged between 18 to 39, focusing on their involvement and the engagement trends.
So you might have a question, what are things we did? So we started with population. In population, we analyze how it's going to be the population trends for Archdiocese of Seattle.
Seattle's population is growing at a rapid rate, making it one of the fastest growing cities in the United States of America. But despite the population of Seattle is growing at such a rapid rate, the total number of households, or simply the parish population, is declining dramatically. So the organization wanted us to estimate the future parish population so that they can make efficient strategic pastoral planning. The chart that you see on the screen shows that based on the past data, the future parish population is estimated to decrease even further. But it is important to understand that this analysis does not include certain external factors such as the faith in religion or the demographic shifts that might happen in the future.
Now we'll look into the cultural dimension, where we are going to look into how each groups differ from each other and how it shapes the parishes.
This shows the top 6 languages spoken across the Archdiocese of Seattle, topped by English with around 52,000 people. And what stands out is the presence of Spanish and Vietnamese, which together sums up to more than half of the English-speaking population. And then comes Korean, Chinese, and Polish language population. Though the count are small, but we can see how culturally diverse is the organization as a whole.
In this chart, we are able to see scaled households, especially with these two cultural communities, Vietnamese and Spanish. So we can see Vietnamese is having a steady growth from 2008 till 2022, And when it comes to Spanish, it's raising from 2008 till 2017 and it's dropping. So as Spanish is one of the largest community, we are trying to look into the what are the things that we need to focus on.
Spanish community is one of the fastest growing as we have seen in the previous graph. But to understand it even better, we have a geographical view of the Seattle area, and this map shows the population density of the Hispanic population, and overlaid on this map are the parishes, with the orange ones being the parishes that do offer Spanish Mass and the yellow ones do not offer services in Spanish. It is interesting to note that the locations where the orange dots are present, it also has high Hispanic population. This means that the organization is being responsive to the demographic changes that have happening in the past, and they are aligning the parish services to the community needs. The middle area that you see, which is marked in red, is a major area of interest for the organization. It has high Hispanic population, but it doesn't have any parish that do offer Spanish Mass. So it could be a potential opportunity for the organization to look at for efficient pastoral planning and for possible outreach.
Parishes offering masses in multi languages affect parish population. Here we have done t-test to find out. It compares two groups whether they both are significantly different with each other. Clearly shows the significance of parishes, how they are significantly different. Here we took parishes that are offering masses only English language and that parishes offering masses in multi languages. Average confirmation Spanish language percent, baptism, communion, and mass attendance are the top 5 variables we got. So these are the significant two parishes that are offering masses in multi languages. This clearly states that parishes offering masses in multi languages that are people feel comfortable and connected. This improves parish life. Here to know whether TOS structural change impacts. Here similarly we have done t-test. So that is what the transform from mission to parish and that will establish the parishes. Here Spanish language mass count, average funeral, other language mass percentage, single individual household percentage, and first communions are the top 5 variables that are significant to parishes that were transformed from mission to parishes.
To see what sets parishes apart or what groups them together, we did a statistical method called Principal Component Analysis, or shortly PCA, which would reduce the multidimensional demographic variables into a set of key components. The graph on the screen shows the results of PCA along with the k-means clustering, and it is plotted against our principal component 1 versus the principal component 2. Each dot here represents a parish and each color represents a group of parish which has similar characteristics either culturally or household wise.
So we will look into the first principal component, which explains the 23% of the variance in our data. It comprises of these 6 top variables, that is African American, Black, White, non-Hispanic percentage, single percentage, Korean percentage, diverse percentage, and married percentage. Like what does this stat mean is, when it comes to this cluster, which is having the parishes which are having a high PC1 value, demonstrate these people will be higher in value. So we can concentrate on them for the outreaches.
And this shows the principal component 2, which summarizes another 10% of the variance that we see in the data. So here it is driven by the Caribbean, Southeast Asian, Filipino, Middle Eastern, and Japanese population ratio. Interestingly, we also see that it is negatively correlated with the population those are married. So from the graph, we can see that the parishes that fall with higher PC2 values are culturally diverse and also has fewer married persons in it.
Now we will look into the young adult, how young adults participate and what are the things young adults are interested in.
So this chart shows the age distribution of Regis parishioners. And the yellow box highlight our focus group, young adult aged from 18 to 39, who make out 29% of total Regis parishioners. And that is a big portion of parish community. And next, let's take a look how young adults connect with the parish over time. We are looking at two kinds of participation, cumulative multi-share and active multi-share. Multi-share here refers to the percentage of young adults who are connected to the parish compared to the total young adult population in Western Washington. The green line is active market share. It counts only those who are already registered at that specific year. So this can reflect the real-time connection. As a result, we can see the green line has been raising in the recent year. So that means more young adults register earlier and the outreach efforts are working. And the blue line is cumulative market share. It tells us how many young adults eventually register with the parish by 2025. So even they join later. So this can give us insight into a long-term engagement. When we look at both lines together, we can get a fuller picture. We can see how many young adults are participating right now and how many are stay connected in the long run. And next, let's compare the change in the young adult population and the change in the number of newly registered young adults. The blue line shows how the young adult population has shifted over time, and while the yellow line is the change in parish registration. Although the registration generally increased, we noticed that in the certain years like 2018 and 2022, when the population saw sharp growth, the registration didn't raise in the same pace. So this suggests that although the outreach efforts are working overall, there were some missing opportunities to engage new young adults during a key moment of population expansion. And finally, let's take a look which parish factors are closely linked to the young adult participation. As a result, we can see baptism has the strongest positive correlation, and following that is our revenue, Hispanic Latin count, and on the other hand, Polish language use and funeral counts has a negative correlation. These are often linked to older or more traditional communities.
Synthesizing all the outcomes that we have found, we are putting together recommendations for the leaderships. These are the recommendations.
Based on the insights that we have seen earlier, we have certain recommendations for the organization. Firstly, the language alignment. Introducing Spanish language masses, especially in the locations where there is high Hispanic population, to bridge the current engagement or community gap. Secondly, the resource rebalancing. Shifting Spanish masses from overserved areas to underserved parishes to ensure broader community reach. Thirdly, empowering the young adults. Establishing ministries, events, and leadership opportunities in locations where there is high young adult participation so that they can do long-term sustainability of the growth that we have.
Following that, we should also look into the predicted 1% decline in population in the upcoming years. So we should have a new outreach strategy, like digital outreach strategy redefined, and also strategical mergers to be planned. Following that, even there are some parishes who have lower participation, so we can focus on re-establishing the sacraments. Last but not least, the cultural epicenters. As the cultural epicenters are changing with the population, we should define new mass languages according to the population movement.
Firstly, I would like to acknowledge our project sponsor, Archdiocese of Seattle, for giving this opportunity to work on this project. And next, thanks for Project Center for bringing up this opportunity. And big thanks to our faculty advisor, Dr. Ariana Mendigle, and our program director of data science, Dr. J. McLean Slaughter. And finally, I would like to thank Seattle University for collaborating with AOS and bringing this project. Thank you.
I have a question about the slide where you compare the growth in different languages. I think it had English, Spanish, and Vietnamese, and it was scaled. So I think it looks like it was scaled. There was each language set was scaled within each group. So the Vietnamese language participation was scaled with each other. Spanish was scaled with each other, and English was scaled with each other. And it looked like Vietnamese was increasing. It looks like the Vietnamese one was increasing.
Yes.
I'm wondering if how you might interpret that, because I think it's, I think the increase is like percent increase, so this might indicate, just because Vietnamese compared to Spanish and English, sorry, I mean others, was slightly smaller, so it takes less people joining to show like a larger increase, whereas maybe it might take more people joining the Spanish community to indicate a larger increase. I was wondering if there's any, how you might perhaps like set like a confidence interval just to show that, because the population is so small, it doesn't take too many joining to increase it. Yeah, I was wondering if you just say a bit more about that.
Definitely, because the reason that we did this is because for instance, the Vietnamese community is about 7,000 or 8,000 people, but the Spanish is 42,000 people. If we include them in a similar line graph, it is not a best way to do it because the comparison would not be good, especially when we are discussing about whether which one is decreasing or which one is increasing comparatively. And I do agree with that because percentage wise, it would be a much more better if we use something, but including all of them in a similar graph without scaling it would not be appropriate for this analysis.
Thanks.
So related to the recommendation you made around investing resources in those cultural sort of epicenters, beyond just kind of population shifts and looking at the expected populations in a region, from the data sets we were able to give you around sacraments and mass attendance, those sorts of things, what kind of data pieces should the Archdiocese of Seattle be looking at in terms of trends over time to predict where should we place resources in the future so that we can be proactive with especially our language resources rather than reactive? If that makes sense.
Firstly, we need to collect the information who are active people who are coming, because we just have the counts of people who are there. We are not able to exactly know that what people are actually attending. So assuming there are young adults attending, but we are not able to get the correct information of how many young adults are there, are they even participating in that particular. If we have those kind of information, we can most probably point out this place needs this kind of thing. Because we are seeing it as number. This many people have attended and this many people are registered. But all registered people are attending, we have no idea. So we need more information, more specific to the particular parish. We need more we need to gather information of who's attending, what is the age group. Like not in respect to the name, like their information other than their name or any other personal information.
So more demographic information about
Yes.
mass participation rather than registered households.
And I'll also to add to that, you can introduce a survey that would get people's attention on what they expect out of the parish. Instead of collecting the mass attendance and other sacraments that happened, you could proactively give a survey that expects what is the outreach that people are expecting for each parish. In that case, you can know the future population and what they're interested in. With that data, we can do the same analysis to see the epicenters.
Have 3 more months to work on this project. What other data sets or features would you like to incorporate?
As you have seen, we've created a graph for Spanish, and we would like to explore much more languages, just the Spanish. For example, finding the hotspots where there is high Vietnamese population, but there is no parish which does offer Vietnamese mass, for instance. Or diving much more deep into the language parts of it. That is one area that we will look at.
Also, we can do the future prediction for the mass attendance and individual sacraments as such, instead of the parish as a whole. We did the future prediction for the entire parishioners, but we can extend it to the number of people attending each sacraments or any outreach program that you wanted to specifically see in the
Did you happen to look at how this aligns with the seminaries in terms of recruiting specific language potential priests? Because when I look at resource balancing, in shifting resources, how much resources does the Archdiocese have to shift? And then how far out do we have to start predicting and start doing some additional work to go ahead and bring some, whether we need Spanish speaking or Vietnamese speaking seminarians into the pipeline, and how do we go about doing that? So has any thought gone into that aspect of it?
There's definitely thought gone into it, but we have not really have data or have not gone into it that deeply in the entire course of it. But that has we discussed about it, and that's a really good question because understanding what the Archdiocese can do is important, but we have really not gone into it.
Thank you.
Okay, let's thank our speakers one last time. Thanks, everyone. Our next speakers are going to also be from the Archdiocese of Seattle, but this time they're talking specifically about the Office for Catholic Schools. So let's welcome our speakers.
Thank you for being here. We are the team working with the Archdiocese of Seattle's Office for Catholic Schools, and we're excited to present our project. It focuses on improving the operational health of the Catholic schools in Western Washington. So before we begin, let us introduce ourselves. I'm Rudy.
I'm Dileshwar.
I'm Abhishek.
And I'm Bea.
So also let's meet our sponsors. Our project has been supported by Archdiocese of Seattle Office for Catholic Schools, which oversees 74 schools in Western Washington, which serves over 22,000 students. These schools have a very high graduation rate of 99%, and which is very much higher than the national average of 89%.
So despite the strong educational outcome, the school are often reacting to the issue related with operational vitality at the level. So the Office for Catholic School want our team to help them identify which variable or measures that can be viewed along also together. That's a leading indicator for operational vitality. So the overarching goal is to help the school move from reactionary policy into proactive interventions.
So the question that we had in the starting was what is operational vitality and how do we kind of measure it? So when we did a bit of research and had discussions with our chat-time conversations with our sponsors, we come to find that operational vitality can encompass many things, starting from the feature, starting from the financial trends to like the operational efficiency, to the student faculty well-being, and also the factors which help in the fulfillment of the like the causes or like the concerns which for the Catholic education.
So given the data that we were provided and the questions that our sponsor had, we narrowed our project scope and we defined 2 project objectives. So the first was to identify some relevant financial health metrics for the Catholic schools. And the second was to try to understand how external community factors impact the financial health of these schools.
So we have conducted a statistical analysis and have developed some predictive models on the same, which have been shared through dynamic dashboard, and as well as we will be sharing a final report on the same. So let's talk about the data what we have worked. So we have the data of all the 55 schools that we are working on for the 5 years. Along with that, we have the school characteristic data like the enrollment and the staff sizes. Along with that, all the financial aid applicants that we have. We have also utilized some publicly available data like the census data of the neighborhoods where each schools are presented. The public school enrollment and the testing results. Along with that, we have the private school enrollment data within each parish.
And with all the data we have, we authorize the mapping software with various boundary file to merge the Catholic school with the census data by zip code and zero code for the booklets and other private school data to create the final data set for further analysis and modeling.
So after data wrangling, our first step was literature analysis and the expert data analysis. We found the Journal of Catholic Education to be very informative and help us in guiding in the right direction. We performed a robust expert data analysis where we were trying to identify the relationship and the patterns in the financial trends, school characteristics, as well as the operational like the features which we consider. And we used the Pareto analysis as well as the time trend analysis as well as the correlation analysis for C.
So we utilize the Pareto analysis to understand the financial data of each of the schools and to understand how what's the major drivers to the net profit calculation. So the Pareto principle says that 80% of the outcome is a result of 20% of the costs, and we can see that here. We can see that tuition and salaries are the major drivers in the calculation of net profit loss. And this is really helpful for us because we know that tuition and salaries are relatively inflexible, so we need to help the schools find other effective strategies to improve net profit and reduce costs.
So to further identify the financial health matrices, we actually divided these schools into major 3 budget classes, known as namely the deficit, balance, and surplus. So we have also completed some analysis of the top 5 and lower 5 of the school, of all the schools, as per their profit and loss per student. We have done the NOAA test on the same data to check whether these groups are actually having some statistical importance or it's just a chance, by chance we are getting any relation.
So one of the important findings from our NOAA test were like the average capacity utilization for all the schools is a factor which is statistically significant. And when we compare for the net profit and loss, when we compare the top 5 and the bottom 5 schools, we end up seeing that the bottom 5 schools have a higher average capacity utilization than the top 5 schools. So when we compare the same average capacity utilization for the surplus, balance, and deficit the groups that we created, we can see the surplus had the highest average capacity utilization, while the balance and the deficit, when we compare, the deficit ended up having a higher capacity utilization than the balance class. So one more thing, we expect like a higher enrollment means a good balanced budget, but that's not the case always. One of the other important points that we had from our NOAA test is that for like several revenue streams were helpful in financially or like separating the financially healthy schools from the struggling ones, and only there was one cost factor, which was repairs and maintenance, which had a meaningful difference. So when we saw for the deficit schools, we see that they have a higher enrollment capacity, but when we also the costs are comparable to the surplus and the balance, but when we see they are not able to achieve the revenue diversity to become like financially stable.
So, to understand the external factors that impact the financial health, we turn to predictive model. And so we developed two models. The first model predicts the net profit loss of the schools, and the second one simply predicts whether the school is going to end up in the balance, surplus, or the deficit. And these are the models that we chose to test: random forest, regularized regression, multinomial logit model, and the linear discriminant analysis. And we chose these models specifically because of our sample size, and because these models not only can predict whether or not the school is going to be financially healthy, it can tell us exactly what factors matter the most in making that prediction. And that's important for us because what we want to know ultimately is what is those external factors that are impacting outcome. And so we utilize a time-based split for our data set. So that means we trained and tested on the data from 2018 to 2022, and then we predicted on 2018 to 2021, and then we predicted on.
And for the modeling, we attempt the regression model to predict the net profit loss, which achieve the good accuracy on training data, but unable to generate the new data. Also, at the benchmark model, we utilize the naive Bayes, which achieve 39% accuracy for classifying the purchase losses, which is less than random guessing compared to other performance model.
Our models which we use for classifying the deficit balances of the budget classes, they performed well for the test accuracy. Our models, random forest model had an accuracy of 70%. But when our simpler models, when we saw, they were overfitting and were tailoring too close to the training set. So when we used multinomial logic model, it had an accuracy of, like, with a mild overfitting, it had ended up having an accuracy of 69% validation mark. And as we see, the results do lie on the low end, but the main aim for our project was to get the variable importance instead of like having classifying our schools in different classes.
So our logit model found statistically significant variables to be median income household, number of total households, renter-occupied units, and the number of public and private school counts to be important factors in determining outcome. And again, we chose these models because they're highly interpretable, and our logit model can provide odds ratios. And so here's just an example of like an interpretation of one of the results. So with an increase, a $10,000 increase in median income, the likelihood of a school being classified as balanced as opposed to surplus decreases by 9.4%. And the likelihood of a school being classified as deficit as opposed to surplus decreases by 21%.
So we will be talking about the random forest variable model. So we have actually got some similar kind of variables which are important in our first model that we have got. That can be the renters of per unit, total household, the median income, and other variables that are related to the school and the demographics. So talking about the models, we have some particular challenges in our modeling. So our data set is small. We have 55 schools and over 5 years of data, which gives us only 275 data. While our data is limited, the main reason for issue was the low variability, because all these schools that we have have almost a similar kind of socioeconomic characteristics. So the model that we have created on this was struggling to get a clear picture and have a clear accuracy. For the future one, if we are going to include more Catholic schools outside Western Washington, these models may perform better and can give a relatively different kind of picture that we have right now.
So despite those challenges, we were able to get some modest performance accuracy, and we did gain some insight. And so we developed some dashboards to communicate and emphasize some of these findings from our statistical analysis of the financial data, as well as our models. And we created a data pipeline so that these dashboards can be updated annually. So with new data from the Catholic schools, as well as we utilize an API to like stream census and public school data. So we created a mock data set so that we can share some of our dashboards with you. And so these are a glimpse of some of them. So this one is our revenue analysis dashboard. And we try to emphasize some of the findings that from the NOAA tests. And so we added metrics like break-even percentage capacity and break-even enrollment. And those indicate, the minimum level of enrollments that the school needs to achieve a balanced budget. We also included a revenue diversity score, which tells the schools, how diverse their revenue streams are outside of just tuition. And this is our cost analysis dashboard. And so the breakdown of the costs can be really useful in helping improve operating margins. And so we've added, so the schools generally had a similar level of expenses, but sometimes a lot of times their expense to revenue ratio is very different. So these metrics, as well as other metrics such as percentage change in repairs and maintenance, can be really useful in identifying, meaningful opportunities for cost optimization.
So here we would be zooming on our Paris characteristics. So here we incorporated all our the insights that we got from our predictive models, which were rental occupied units, average medium income for the parish, then the parish school, the public school enrollment and the public school characteristics that were associated with that region. Later, this would be helping schools with better target and tailor their outreach efforts, plan their teaching strategies, which would ask for the right kind of support which they would be needing later.
So these are the two key takeaways that we have got in our analysis. So maximizing enrollment may create infrastructure cost that operational efficiency elsewhere cannot. Second will be the multiple revenues beyond tuition, which is actually relatively inflexible, but it could strengthen the school's financial needs. So on the final note, to help enhance the operational viability, we have actually found some financial health matrices and different demographic things that actually help a school to be stable financially. So, and some of the things in our dashboard and our analysis can help with the risk mitigation. The administrators can plan, the future planning can be done strategically, and which will be helpful in long-term sustainability of these schools. So on the final note, before Q&A, we would like to thank our sponsors, our professors, and the project center. We are very grateful to all the resources and support they have provided throughout this project. Thank you.
So I know you showed a Pareto chart with all the variables of expenses and revenue. First of all, great presentation. So one of the major places where expense revenue trade-off happens is either financial aids or maintenance renovation costs. So when you take that trade-off, which do you feel affects more, like the financial aid, whether you increase the financial aid, therefore decreasing your revenue, or you increase, focus more on the renovations, increasing your expenses. So did that come out as something that was there? Sorry.
Yeah, I think one of the reasons why we added that metric in the cost, like the percentage change of repairs and maintenance, was for this reason, because tuition and fees are sometimes on a schedule, and it's relatively inflexible. And while repairs and maintenance are maybe a little bit more flexible, it's good to kind of track it over time to see if there is wiggle, so.
So you mentioned, random forest got better accuracy, but severely overfits, and the Logit didn't, slightly lower accuracy. How did you know that? How did you come to the conclusion that it was severely overfitting? What does that mean here when you had the higher accuracy, right, against the validation?
Yeah. So one of the, characteristics of an overfitting model is that you get, this great training accuracy and you have a huge gap between the training and prediction accuracy. So let's say like, the random forest is, a powerful model. So it can reach like 80% in the training accuracy, but then reach, very low, testing accuracy. So when we, so what we tried to do was sort of minimize that gap, which tells us that it's, generalizing to data, to new data.
Yeah, adding to the point when we were doing the random forest model, while we have got the test accuracy of 70%, the training accuracy was almost 90%, 90 to 92% we were getting out of that. So the difference is huge. So that's why we thought of that this is overfitting and there will be a data leakage in this.
And all the time we have for questions, so let's take our speakers down. Last talk of this session is going to be from our team from Puget Sound Energy, so let's welcome them.
Good afternoon. We are MSDS Team 7 and Series Hustling with Electrical. Let me introduce our team. Shiva, Julian, Vesa, Salu, and myself, Team Lee. We are tackling a critical question for energy provider. Let's start with our sponsor organization. Fisheries Energy is an independent power producer across the western US and Canada, as well as the largest energy provider in Washington State, serve more than 1.2 million electrical customers and 900,000 mutual gas customers, focusing on delivering reliable, affordable, and sustainable energy. So now here, imagine you are PSC. Media or switch happen every day. Tracking AC, charging device. How would you keep the grid stable and balance the resources? That is the challenge we are tackling. The traditional model study sees the forest but misses the tree. Those complex and non-linear patterns. And our work support the decision making in 3 ways. Pocket incentive, apply happy hour discount for customers who shift their laundry to off-peak usage. Grid upgrades, fix the energy traffic jam before the heat wave hits. And then the last one, it will be dynamic pricing. Align the actual rate for workers who use energy at 10 p.m. So PSC, the customer that PSC understand the customer real behavior, better for customer, smarter for the grid, and sustainable for Washington. So this graph shows the daily energy cost for PSC's customer. So commercial customer, color in green, start high average energy usage at 2 kilowatt hour, surge past to 2.5 kilowatt hour by 10 a.m. and drop after 3. So residential customer, start low average energy usage hour at blue, color in blue, and then climb slowly through the day and reduce as the routine went down by 8 p.m.
Puget Sound Energy collects electric usage data in every 15 minutes interval, generating a massive data set. However, without a structured approach towards this data, PSC struggles to optimize energy distribution and predict the demand effectively. Now let's imagine PSC as a restaurant preparing meals for 1 million customers every day. If they don't know what or when people will eat, they might prepare too much food, leading to waste, or too little, causing shortages. Similarly, without understanding customer electric usage patterns, PSC faces inefficiency in power distribution and forecasting. Here comes our key question: how can we uncover hidden patterns to improve efficiency? Here comes our project team, applying clustering techniques to group customers based on their energy consumption patterns. To tackle this challenge, we had access to data set of 9,000 plus customers, including 4,200 residential customers and 4,200 commercial customers. This data spans entire year of 2024 at 15-minute interval, resulting 320 million data points. This vast data set allows us to uncover hidden trends and group customers based on their energy consumption. Here are our 4 key objectives. First, identifying common electric consumption patterns. By analyzing the data, we can find common trends how customers use electricity. By this, PSC can help, which can get helped as to predict the demand. Next, clustering customers based on their energy consumption pattern. Not all customers use electricity in the same way. Some have high energy during the day, others at night. By grouping similar customers together, PSC can develop targeted strategies for energy efficiency. Third, improving forecasting and enhancing. By implementing all these strategies, PSC can develop get benefited from energy boost.
When we received the data set from a Puget Sound, we had a very rare opportunity to analyze this data. So we followed a structured approach for this. The first one we had a data cleaning and feature engineering, then EDA, then clustering and validation and implementation. So let's come to data cleaning. We found so many missing images in our data set. For commercial, it was about 200,000, and for residential, it was about 200,000. So, instead of deleting those values, we have filled them with a backward rolling technique. Next, we have handled duplicate value. We found around 2.4 million in residential data and 2.7 million in commercial data. We kept the only highest usage value and removed the other one. Next. Let's come to the feature engineering. It's the most important part of our project. Initially, we only had 3 columns like unique ID and time and usage. So we created features based on time like hour, week, month, season, year, and we also created features based on electricity usage like total load, period, and load category. So suppose one customer is using very high energy and another customer is using very low energy. So compare one of them on the same level. We have done sexual normalization.
After data cleaning, we did conduct an exploratory data analysis to kind of understand the usage behavior among the residential customers and commercial customers. With this on this heat map, it does show the average hour usage by hour of the day on the x-axis and day of the week on the y-axis. The light blue shade is showing the low energy, while the dark blue shade shows the high energy. As you can see, the residential customers do show a low energy consumption early in the morning between 1 a.m. and 6 a.m. That's when people are asleep. And so it peaks around 5 p.m. to 9 p.m. where our return home is starting to use appliances or doing household activities. Next. when we look at the commercial customers, the trend was quite different. The commercial customer do show a peak around 5 p.m., 9 a.m. to 5 p.m., typically reflecting to business hours or hours of operation. Usage outside of these hours is quite low, especially during the nighttime or weekend. So our immediate did clearly show that residential customer and commercial customer have different distinct pattern. So trying to model them or trying to segment them together in one space, it would risk us to miss the key insight specific to each group. So we decided to segment them separately.
Okay, so as we saw in the EDA, commercial and residential customers are very different in how they consume energy. So we want to do segmentation in each of the groups individually. We're presenting three of the techniques that we implemented. Those are the dynamic time wrapping DTW, the hierarchical density base, also known as HD scan, and time series K-means with Euclidean distance. Let's take a look at how we're going to evaluate it. The first is the behavioral interpretability. We want to make sure that the clusters that we ended up having are very different one to each other, and they also represent real world behavior. Second is the scalability and runtime. We want to make sure that we have more than 9,000 customers, and that represents more than 320 million data points. That's a huge data set, and running these techniques in that data is very computationally expensive. For that, we're setting up our threshold for runtime as 3 hours. And also because we want to provide PSC a tool that if they want to rerun these in a large data set, they don't have any constraints. And then we have the silhouette score. That's a numeric metric that tells us how well separated are the clusters. Values closer to 1 means that there is a good separation, closer to 0 means that there is some kind of overlap from one cluster to another. And we're trying to aim to have the silhouette score as close as 1 as possible. Let's take a look at the results. For the first one, dynamic time wrapping. This is a technique that is designed to handle time series data. It tries to capture trends over time, even if those trends change. However, what we saw in reality is that the silhouette score in this case was really low, 0.12 and 0.1. It takes 6 hours to run this technique, 6 for commercial and another 6 for residential. That's a lot of time of running time, which makes it really difficult to escalate. And also, when we take a look at the interpretability, we consider as low. Let's look at the graph. Here, we're presenting in the x-axis the hours of the day, in the y-axis the average of energy consumption, and the colors represent each of the clusters that we found. So we can see that this technique did a decent job in separating in terms of magnitude. We see that it has like different levels. However, when we take a look at the trends, they look pretty much the same. That makes it really difficult for us to create any story around this. In our second technique, HD scan, this is a technique that we don't need to set up the number of clusters. The technique does it by itself, and it's also really good to capture light. However, we saw that the silhouette score in this case is the highest across the table, but 0.43 is also not a very high silhouette score if we're very conservative in the mid. The runtime is around 3 hours, which is just exactly in our threshold. But when we take a look at the behavioral interpretability, what we're going to see is that we consider low and noisy. Let's take a look at the graph. Here we can see that in the top part, it did a decent job to separate both trends and magnitude. But if we take a look at the bottom part, some of them can be summarized into one unique cluster. And also we have more than 28 different labels. That makes it also really difficult for us to make analysis and profiles for each one of them. Moving to our last technique, that's the K-means. K-means is probably one of the most known in the literature. It's trying to minimize the variance inside of the group and maximize the distance from one group to another. The silhouette score in this case was the lowest, but one of the things that we learned is that two customers can have exactly the same average of energy consumption, but one can be using the energy in the morning and the other one can be using the energy in the afternoon. And that's precisely what we are trying to capture. The runtime is less than 30 minutes, so if we provide this to PSC, they can put it in a large data set and they're not going to have any problems. And when we go to the behavioral interpretability, we consider as high. And also because we were able to find real clear behaviors from one group to another, and that's the reason we decided to go with this technique.
So looking at this graph, it does display the average normalized usage by cluster in residential customers throughout the year. So each cluster or line represents a specific cluster within those residential customers. For instance, when you look at the R1, shown in green, it shows a high peak during the summer months, when the R3, shown in dark blue, shows a high peak during the winter. That can reflect to heat inactivity. These clusters execution were resulted from the K-means clustering. It is very important to understand these trends because Puget Sound can enable Puget Sound to design programs that are specific or that this cluster can result from according to each cluster's seasonal needs.
Here we come to the residential cluster. So this analysis shows that 4 distinct profiles from R0 to R3 reflect a different lifestyle that impacts the grid burden and efficiency opportunity. So start from R0, evening peak user. This one reflecting the customer who use like a high energy 24/7, and we can notice their consumption trends tend to dip in the morning and rising back in the afternoon. And cluster R1, high constant user. This one more than likely to reflect a traditional household activity. So as we can see, the consumption trends tend to start at afternoon 2 p.m. and then fades after 8, which align people returning home, cooking dinner, and then it's like running appliances. R2 is our daytime user. We consider this one is more than likely who work from home, as we notice they use more energy during the daytime, especially between like the working hour 10 a.m. to 6 p.m. And the last one is the moderate user. We can see here it's like a relatively flat and stable with no extreme peak usage. So it's only slight dip in the early morning around 3 to 5 and then a mild rise in the evening.
So when we apply time series K-means clustering technique on commercial data set, we found 4 unique cluster pairs, which are labeled as C0 to C3. On the x-axis, there is an hour of the day, and on the y-axis, there is average electricity usage. Let's analyze the cluster C0. Cluster C0 using high energy throughout the day, but in early morning, it spikes up, which can be hospitals or data centers. Next, analyze the cluster C1. It follows a classic pattern from 9 to 5. We can see that in the morning it spikes up and in the evening it starts to decrease, which can be government building, offices, and schools. Let's analyze the cluster C2. We can see that cluster C2 is using high energy, but it's low in the early morning and decreasing in the late night. This can be gyms or restaurant. So cluster C3 is the most unique pattern we found in the commercial data clusters. So it's using a constant energy throughout the day, but it starts to increase throughout the night and decreasing in the early morning, which can be casino, pub, or bars.
To conclude, throughout this analysis, these are the key takeaways. Even though we're not provided by demographic data set from Puget Sound even though we're not provided for demographic data set from Puget Sound for privacy and confidentiality purposes, we were able to get some key insight from this segmentation. The smarter rate design and demand response strategies can improve the grid efficiency and stability. Time of the usage is as important as total usage or total consumption because these can shape the grid load profile and forming decision planning. Another thing that we learned is that segmenting residential and commercial customers separately was crucial to capturing their unique pattern. Also, our pipeline analysis is reproducible, scalable. This means that we are making sure that we can continuously refine this insight as new data becomes available.
We would like to take a moment to acknowledge people who have supported throughout this project. A special thanks to our sponsor liaison, Graham, and a big thank you to Dr. Slaughter, our faculty advisor, Dr. Mendeville, capstone coordinator, and our project center team, who who have continuously supported throughout this project, and we could not done without this you. Thank you. Any questions?
I have a question. So I noticed this time seeing the presentation, if you go back to this like slide 3, it was when you showed the heat map of the residential customers. There we go, that's the guy. So at PSC, we typically treat weekdays and weekends as 2 distinct behaviors and assume people behave similarly on weekends, like Saturday and Sunday to each other, and weekdays, they all behave similarly. But something that I caught here was it looks like Saturday and Friday have somewhat similar evening patterns, and then Sunday's evening pattern is actually the same as a weekday pattern. That's like a quick visual catch, and I'm curious, did you look at any intraday differences to see if there was like a meaningful difference between, say, Sundays and Tuesdays?
So when we analyze this data through the ETA or exploratory data analysis, this visual actually can relate maybe Sundays when people are home and preparing to start a week during like starting another week compared to Saturday. Saturday probably people eat out. And Sundays when people are home and trying to prepare and don't probably much like go out. And you can see that Sunday on this darker side will reflect to not on Friday, it's reflect Thursday to Monday.
Yeah.
And when you look at Friday actually and Saturday, the energy consumption is lower compared to those two lighter blue, meaning that probably people can be eating out. I wonder if that's something that was missed.
Yeah, it's a thing that hasn't occurred to me in the profession before, so that's interesting. Thank you.
So I have a question. So after you do the cost analysis, how to use them if I want to do short-term or long-term forecast for future 1 year demand for electricity or future 1 month or 1 week? So how to use them to forecast?
Okay, so yeah, the scope of our project was basically finding those different clusters and try to understand how they are the behavior. But that's a clear that you mentioned is really important for forecasting, because if we know that there is some kind of customers that are using more energy during the morning times, so for example, the ones that we found in residential, that they are using energy during the day, maybe working from home. So we can easily use this for forecasting that people is going to use that amount of energy in average. However, we weren't able to find any forecasting future techniques because it was out of the scope of this particular project.
All right. Unfortunately, that's all the time we have for questions, but I encourage you, if you still have one, to go find our speakers at their posters, and let's thank them one last time. Now we have a 15-minute break. We'll come back at 2 o'clock for the next session. Just some time to start our second set of our presentations for the Masters in Data Science. This section is going to have a few talks about community and environment. So let's welcome our team from Snohomish County.
Hello everyone, thanks for joining us today. We are excited to share about our project, and I hope you are excited too for our presentation. Our project is about making the connection from community input to the county projects and programs. We are working with Snohomish County Office of Energy and Sustainability, and we are data science students and in 25.8. Myself, Prashant.
I'm Vivek.
I'm Devin.
Now let's talk a little bit about few facts of Snohomish County. Snohomish County is the third largest county in Washington state and is home to diverse communities. Snohomish County is well known for hub of aerospace technologies, with Boeing's largest manufacturing facility in the world located in the area. Now let's dive into our project. The main motivation behind this project stems from Justice Body and other similar initiatives, which mandates some percentage of federal investment in areas like greenhouse gases reduction, housing and energy and many more, must benefit to low-income and disadvantaged communities, simply called LIDAC. This order affects many kinds, including the one our sponsors are interested in. Now, to get these fundings, Snohomish County must submit and conduct surveys, submit the detailed report proving that they are addressing the LIDAC needs. Now let's discuss the problems we face in this project.
So when we started working with the county, they have approached us with a set of problems in four major areas in the current workflow. First is the fragmented data intake. Currently, different departments in Snohomish County conduct the same surveys to its residents through fragmented survey tools. So this leads to duplicated work as well as frustrated residents. So all these collected survey responses are not stored in a single location. They are all siloed and scattered across different departmental locations. So this will make the analysis complex as it is time consuming and error-prone. So when it's time to process and analyze the data, the Snohomish County hires external consultants who analyze the data using traditional statistical tools like SPSS, Tableau, R, and many more. So this analysis is costly and very time consuming as it would take weeks for them to produce the insights. So finally, this analysis produces static PDF reports so that it cannot update in real time. So our goal is to fix all these problems through a solution. So when we wanted to fix this problem, our team has proposed an initial solution which consists of four major steps. First, we wanted to collect the entire legacy data of the surveys conducted in the county and then which are mostly in Excel spreadsheet formats with a wide range of formats. So we wanted to build data parsers which are used to clean and transform this unstructured raw data into a clean format, which are database ready. So these parsers read a data file of a known input format and then transform that into a clean format which makes the analysis easier. So after the parsing is done, we will store all this legacy data into the centralized database, where the developers can perform the query easily and fast. So finally, working on this centralized data set and performing data analysis, and then finally producing reports is our final step. But when we started building the data parsers, we have faced few challenges in it. So as you can see, this is a picture of a raw data we received from the county, which is from a real survey. This has repetitive questions and multiple headers and inconsistent formatting. So building parsers of a known format is fine, but what if the new survey has a different format? So this is going to break our parsers and it would consume most of our development time in building and cleaning the old raw data instead of analyzing and focusing on the bigger picture. So all these challenges made us think that the building parsers is not a robust solution as it would consume a lot of our resources and waste most of our development time. So our team has decided to switch to a new solution where we get the clean data right from scratch instead of spending time in cleaning the data. So our solution is a centralized system which is fully automated and consists of four major components. So this addresses all the four major issues facing by the county, and this is going to solve it. The first is rather than building the parsers and maintaining them, we built a centralized survey platform which consists of a survey portal and a survey data. Now, every department in the county can use this unified survey system to conduct their surveys and also expect clean data and not accounting messy data anymore. So when the survey results are in, we are going to store that in a centralized database, which is Azure SQL database. So no more scattered data and siloed data sets. So in order to process the entire survey data, we built a clean extraction and summarization pipelines
which uses LDA-based topic modeling and a large language models. So this will extract the key themes and most raising concerns all over the counties, along with producing some general insights. So instead of static PDF reports, we will be delivering our entire results to a Power BI dashboard where administrators can filter the results via zip codes and can view the real-time results along with themes and most pressing concerns. So as such, you all know the problem and the solution for a project. Let's not talk about the current methodology the county is using.
Before automating the LiDAC analysis, let's understand what the current methodology is. Taking the recent LiDAC report as an example, the report contains 4 sections: background, quantitative analysis, qualitative analysis, and comparative analysis. But for our project, we will be focusing only on automating the quantitative and qualitative analysis. Current methodology for the quantitative analysis is that it performs only on 3 types of responses, that is number format, single select and multi-select format responses. And the analysis is divided into summary and table of data. And next, in qualitative analysis, it performs only on text format responses. And the analysis is divided into the summary and the direct quotes from the text responses. Let's talk about the implementation.
So our implementation begins with intake. Here we have built 2 applications, a survey portal and a survey builder. The survey portal is used by residents to provide new survey responses, and the survey builder is used by county administrators to create new surveys and questions. Then these data will be stored in our centralized database, which will then be processed by 2 core pipelines, the theme extraction pipeline and the LLM summarization pipeline. So, as Vivek mentioned, there are 4 types of responses in a survey: text, number, single select, and multi-select. The goal of the theme extraction pipeline is to condense these 90 text responses into a single word that represents the respondent's concerns, and we call this a theme. It does this by first fetching the text response, performing some pre-processing steps on it, such as in smaller chunks, and removing connected words that could be or and that doesn't much meaning. And then it will perform topic modeling, produce a cluster of words by topic, which will then feed into a large language model and ask it to label the topics for us with a single word, like wildfires, housing, and dogs. Next, the LLM summarization pipeline will produce a summary for each question separately. It does this by collecting all responses for a specific question, combining them, performing some pre-processing steps again, such as calculating the response distributions, attaching zip codes, and contracting the final instruction to the large language model. And then we will feed it to the LLM, and finally it will produce a concise summary that highlights only the key information that somebody like the county administrators need. And finally, all the survey data and analysis results will be shown in our Power BI dashboard. Now we'll give a brief demonstration of our text.
So now let's look into the demo of the survey builder, portal, and Power BI dashboards one by one. So in the builder, we can create a new survey, give a survey name, organization name, set the starting date and ending date. We can also edit the survey, add questions. While adding a questions, we can mark it as required and choose the text type, like whether it is text, number, single select, or multi-select. For single select and multi-select, we can add options as needed. And for the text type questions, there is a placeholder text to guide the respondents. And for the number type, we can provide minimum and maximum values. So once the survey is ready, we can copy the link and share it with the residents. The residents can open the link and they can start the survey right away. They can see the title, the organization, and go through the questions one by one. Once the survey is completed and submitted, the responses will be stored in the database. Now, the final result, the dashboard. It consists of 4 main components. On the left, we have the survey selectors, which consist of all the available surveys, pulling data in real time from the database. The users can select a survey and the dashboard will show the relevant responses and visualizations.
In the middle, we have the county map, which we created using the shape map, where responses can be filtered by zip codes. On the right, we have the question level breakdown, where we can do cross-filtering. For example, if we click on any part of the chart, the other visuals will update automatically, and we can select separate questions using the slicers, and the charts will update automatically according to the selected questions. And this section also has the LLM summarization, which is a short summary related to the questions selected. And below the map, we have a tree map, which will show the themes extracted from the text responses, which help us understand what people are more talking about the community. Now we will look into the further details.
Now, let's discuss key takeaways from this project. Previously, each department has its own tool to conduct survey. These leads to messy and duplicate data, and mostly they are relied on costly external consultants. Now, without centralized system, we are eliminating this costly external consultants and providing better cohesive workflow. And the county can take smarter decisions using real-time data. And finally, our project makes huge impact. In a way, it reduces survey fatigue, saves time and money, and county can take serve just low-income and disadvantaged communities better and meet justice for the requirements and other similar initiatives. Now let's talk about our future work. As we mentioned earlier, we focused on quantitative analysis and qualitative analysis in this project. We need to implement automated comparative analysis, which we need to focus on. And finally, in the Power BI dashboard, we need to implement different visualizations which adapts to the data. And it will be helpful to the county if we migrate the current existing data into our current system. Before wrap up our presentation, we would like to acknowledge few people who supported throughout this project. Thanks to our Snohomish County listeners for trusting us in this project. And special thanks to our faculty advisor, Dr. Natin Slaughter, and caption coordinator, Dr. Ariana Mibule, for guiding us in this project. And thanks to Seattle Project Center team. Thank you. We are open to the questions.
When you built the LLM system to summarize the survey responses, did you build any metrics around testing the accuracy to make sure the LLM isn't just spouting?
So most of the testing is done just qualitatively, right? We take a look at them. Let's say we submit 3 responses and 2 of them said they used buses as their primary mode of transport and one of them uses a car, and we can see in the summary that the numbers are correct. We didn't perform exhaustive testing, but we also compared it to the original 1.3 LiDAR report, and then our summaries tend to be about roughly similar length and roughly similar level of detail.
Which LLM did you use?
So in our case, the specific model isn't particularly important. We didn't notice too much difference, but right now we're using GPT 4.1 mini. Previously, we tested it on 3.5 turbo, but that's getting aggregated soon in like a month.
Dr. Puget, I'm curious what your plans are to make sure that the county can maintain the software for the future.
So that was a big focus of this entire project. We actually spent a lot of time automating the infrastructure setup. All of this is live right now, which if you come to our booth upstairs, then you can also play around with it, or if you have your own laptop or something, you can copy the link and play with it too. All of this is on Azure, and we build infrastructure. Let's say we hand this off, this entire repository to Snohomish County. They can run a single script, and it will spin up all of the resources and connect everything together using ARM, Azure ARM bicep scripts. Aside from that, we also have plenty of documentation with like since we have limited time, some shortcuts have to be taken. Particularly, you probably don't want random people to be creating new surveys, building surveys, so we need to have access control. But all of that kind of pitfalls are documented.
No more questions, we'll take our speaker again. Actually 2:20 when this is scheduled, so that everyone who wants to come to this presentation can enter. So just being on the lookout for a couple of minutes and we'll get started. This is with NOAA Fisheries, so that's on our campus.
Hello. Hello, everyone. Thank you for being here. My team and I have been working with NOAA Fisheries on a model approach to Pacific salmon research and online dashboard. My name is Maïlis, and here are my teammates Lavanya, Rukaya, and Gary. Let's talk about NOAA now. NOAA Fisheries is a governmental agency that focuses on environmental research and salmon and marine life system. Their goal is to ensure the sustainability and productivity of fisheries, maintaining safe sources of seafood, preserving vulnerable marine species, and promoting a hydro ecosystem balance. Now let's talk about salmon. Salmon go through 5 stages of life: egg, larvae, 5 small and adult. And understanding their life cycle is important for researchers because it helps for their life cycle modeling, conservation effort, and fishery management. And as they transition from freshwater to river, they face some environmental challenges that impact their growth and migration. The challenges that they are facing are temperature, sediment, water flow, alkalinity, water depth, and cover. And those stressors act as environmental drivers that impact their habitat conditions and feed into their life cycle that provide a life cycle model output, which is good for researchers because it helps them understand how salmon responds with those changes. The importance of our work, of the research that we have been doing, we want to, because it brings the data together, meaning that it makes the data useful, accessible, and decision makers for researchers. It also fosters collaboration across discipline and drives smarter and faster decisions for a healthy ecosystem, since they are important for healthy ecosystem balance. Now, Lavanya.
Well, this is a representation of a Drupal-based dashboard, a legacy dashboard which currently NOAA is using. It stores and manages all the research articles related to NOAA, and it consists of 150 plus articles in it. And also it have a features like searching over articles by using a metadata field, and also it have a uploading and download options. Why NOAA want to get this legacy dashboard with a new version of dashboard? What are the challenges they are facing? First difficult challenge is accessibility of an articles, where articles scattered all over the internet on different platforms and websites, which makes a researchers to find the article quickly. And also reviewing process of the article is a time consuming process. Where the legacy dashboard built in a Drupal, which is not aligned with the goals and policies of NOAA, where even though Drupal is like a open source platform, to build or maintain any website in a Drupal, it costs from 5K to 20K on the cost, even more. It depends on the complexity of an app. The Drupal also requires advanced coding skills like CSS and Java, where NOAA always comfortable with R programming. There is an R Shiny tool on top of R, where we can build interactive dashboard and very easy to use and requires limited coding skills. And also where NOAA tools are very well aligned with R Shiny and especially with the integrated toolbox. As addressing all the challenges occurred in NOAA, as a team, we came up with a capable solution. First and most important thing, we built a brand new dashboard in R Shiny, which is very easy to use and finding an articles is very quickly. And also we introduced the advanced features along with the existing features from the legacy dashboard. By using the best data engineering techniques, we migrated the old data into a new MySQL, which is very well organized and easy to use and maintained. One of the most important part of the dashboard we designed based on its scalability and long time performance. Now our journey will be continued by our team.
Now let's talk about our journey from raw data to a dashboard. We began by exporting all existing articles from NOAA's legacy dashboard, and it was a standalone GeoGebra. And we quickly realized that while a JSON file is good for some basic data analysis and data storage, it wasn't going to be an ideal option for our dashboard and for long-term use at NOAA. So figuring out the data storage mechanism was the major part of this project, and then only we built our final dashboard. And during this process, we also explored our data and found some key challenges in it. And one of the main challenges was inconsistent terminology and the classic problem of duplicates. So if you see on the right, there is a bar plot that shows top 10 life stages in our database. And if you take a closer look, you will see that there are same life stages but different versions like lowercase and uppercase. This was caused because in the legacy dashboard, they had text fields where users were having the freedom to input anything. So this was one of the main challenges, and we had one more. Long comma separated strings. If you see on your right, there is a drop-down of geography field that is a metadata field in our database. And last field says Alberta foothills watershed, comma, excluding national parks, which is awesome. It's descriptive and helpful. But for a dashboard, we needed something more meaningful, so we had to split this into different multiple fields and do some cleaning. And while we did that, we also switched to a different database called SQLite. Now, let me tell you why we did that.
So our JSON database, as you know, it had inconsistent and nested structure, which made it difficult to query. And in our dashboard, we also wanted the ability to upload new data. And while JSON is good, but uploading new data means we would have to write data validation code from scratch. So that was one challenge. And then it had a single point of failure. If you know JSON, you know that even a simple syntax error could crash the whole application. And then all of these reasons make it not scalable for us. And also this database is growing at a faster pace right now. So that's why we had to move from JSON to SQL. Now you might be wondering, we had 100 databases out there. Why SQLite? So there were a few reasons. First, it had a structured and tabular format, which made it really easy to query it, and the querying became effortless. Second, it had a built-in schema and constraints, so we didn't have to write any data validation code from scratch. And then there were two more reasons, and these were the deal breakers for us. So it smoothly integrates with Archdiocese, which NOAA was comfortable with, and then it comes at no extra cost. So they wanted something open source and free of cost. So all those reasons made us switch to SQL. Next, let me show you what we built. So NOAA Fisheries gave us 3 minimum requirements. First, to build a searchable and filterable database where users can search for articles using different metadata fields. Second, each article should have a detailed view where users should be able to see entire information about that article along with the interactive graph. Third, the user should be able to download any article as a CSV file. Next, we didn't stop here. We built something above and beyond because NOAA gave us the freedom to be creative. So we built these advanced features, like we added the ability to upload new data, and we added an admin panel where admins can directly manage the database through the UI, not through backend. And then we added some new metadata fields, some UI enhancements, and we added some additional pages like welcome page and data analysis page. And we also made our filters reactive and dynamic by using database lookup tables instead of referring to the main table. So those were some awesome updates that we did, and now I'll let my teammate continue and show you those features in detail.
All right, so we're gonna go through a quick dashboard and action session. So we're gonna start with where the user winds up when they click the link or click the toolbox link and for NOAA. And that is this home page. We went back and forth between a welcome page and a home page being where the dashboard actually happens. And we figured starting here would be best so the user doesn't have to click multiple times to get to here. This page has pretty much everything a user would need to interact with both the articles, seeing the metadata, and getting any of the filters and other tabs available to them. So diving into the user flow a bit here, we have about 150 articles. And so once they're in that, we want them to be able to filter these articles because 150 articles can be a bit daunting at first. So these filters are not necessarily the exhaustive list, there might be more added later on, but we made sure to add in some additional filters beyond what we started with, such as splitting out that geography region because, as Rakai mentioned before, some of those geography regions have those common separated fields. We want to make sure that we allow that to be split by country, state, watershed, etc. Once they are in these filters, they can select multiple things in a filter and all other filters will react to them. So they chose connectivity or depth or both. All other filters would adjust themselves to only showcasing items that are related to those articles so that at most times there is at least one article shown on the homepage. Now, once they choose an article that they want to click into, they are brought to this page, which is currently all collapsed so that the user isn't inflated with a bunch of information. So we'll start off with the article metadata and the description. The metadata is pretty much exactly what's shown on the home page with a couple of new pieces that are a bit more direct to the stressor. And then we also have the description and function details, which is either an article description, a description of something in the article, the abstract of the article, whatever the uploader wanted to include in that, and then how that article came about or a description of the stressor. We then also have these data tables that showcase the actual stressor data. So once that data is up there, we can also include an interactive plot that if you hover over any of these points on the plot, you'll see anything on the table itself.
Once the user chooses a couple of articles or they feel like one article is enough, they can then export the articles on the homepage. So we have the option to either export the entire database if they are really loving all the articles they see, exporting selected, or exporting everything they filtered for. But we don't want to stop there. We wanted to add the ability for this database to expand and keep on gaining articles that are found on the internet. So, as Rakaya mentioned, we have a guided upload feature where there's drop-down boxes that users can input all the information they need to using these drop-downs that are pre-populated with what's currently in the database. And once they do that, add a CSV file for the stressor data, they can preview the data to make sure it all looks good and then upload it to the database. From here, we also, if those rigid drop-downs have something that, or don't have something that a user wants to add in, they can then go to an admin and say, hey, can you add that in? So admins can go into the password protected tab, add in a category to any of those drop-downs to allow users to add new information to the database. That way users can't just add everything, and there's a couple of checks and balances. There's also the ability to delete entire articles and eventually the ability to edit anything in the database as well. And then finally, we have a couple of additional pages, such as the welcome page that showcases information about NOAA, the app, and the team that helped build it, as well as an exploratory data analysis page. So a user at any time can go in and get a quick idea of what all is in the database. And now, to conclude, this database is super important to help bring conservation research together, as opposed to it all being scattered across the internet. This won't just stop at salmon, hopefully, and will end up being a national level item. And it'll hopefully bring everything researchers need to get conservation for fish and wildlife in one nice place. We'd like to acknowledge everyone at NOAA Fisheries and Seattle U that helped us with this project, because without them, this wouldn't have gotten this far. And then we also would like to thank you all and invite you to scan the QR code for a demo of the app on your mobile phone. Or if you have your laptops out, feel free to type that link in for the non-mobile version. And then also, if you have any questions, we're happy to answer them here, or our booth is right outside that door upstairs.
One of the things that I know NOAA does is they collect data for years and years and years. Does your software package allow people to add data to data files that already exist? How do they deal with data files that change in time?
Do you mean, is there any ability to revise any existing articles? So on the upload page, we currently have a placeholder for a revision log where users can make changes to the existing data. But that is currently a placeholder because of the time constraints, we could not implement it. So that's there, and that's a very important feature as well. Yes.
Just really quickly, so for the articles that are being uploaded, are they peer reviewed? And is the information best available science?
Yes, so currently we have a new metadata field called article type, which shows what type of article is this. Is this a review? Is this a study or something that was done on the study? So it's all review and it shows the credibility of the article. And the article itself has citations, which takes you directly to the study. So you can see that as well. Jesse?
Something I was curious about. One difficulty is that, for example, the geography or region column might look really messy and might be non-uniform or might contain too much information. When you went about cleaning that column, did you do it? Is there any way to automate it, or did you have to do it by hand?
Well, my first thought was to do automation, but then NOAA gave us a file where they manually cleaned some of the data, and that was really helpful. So we just split. We had to split that region column into different fields like river, country, state, and so on. So that was really helpful. I think most of the work was done by manually cleaning it by our team and NOAA, and the rest was done by automation.
Also to add to that data cleaning, so since we only had 100 or so articles at first, we really wanted to make sure that it was good to go, which is why we did it a bit more manually. But we are hopefully going to add in, if we have time, a additional thing to the admin tab that allows them to select certain columns in the database and adjust any verbiage in there in a semi-automated way. We still have to type in what we want it to be. That'll be admin only, so only NOAA's allowed to touch that one.
So you talked a lot about some of the fail safes or kind of robustness of your app. Is there some kind of like future proofing that you haven't done yet or failure points that you anticipate that we need to address?
Yes, so currently, the most important feature in this dashboard is our upload tab, where we could do a lot of improvement. For example, okay. So, yes, since we're handing this over to NOAA, one of the main features that they will also work on is the upload tab, where we can make a lot of improvements. And the reason for that is because, as you saw, there were several challenges in this data, and those are just incoming challenges that will never stop. So we have to prevent those as much as possible at the upload, so that we don't need to do any manual cleanup anymore. So I think that would be the major next step.
So you mentioned that you want to expand it to other than salmon species and all. So what do you think will be the time or the effort taken to do that?
Well, currently it took us 5 months to build this, and it's still not there yet. So NOAA is going to take this and expand it further. So yeah, but one thing is for sure that Archdiocese is really easy to build something on. So initially when we were learning about Archdiocese, we actually built some sample apps and it took us no time. So yeah, it depends on your use case, but it's really effortless, especially for people who are not developers by profession.
And since they are research articles, as long as it fits the format, technically it can be added through the research article process.
Well, hi, Ed. Well, first of all, great job here. Yeah, taking the iconic salmon is so important in the Northwest. I imagine, or is SU, if not NOAA, would SU be looking at scaling this sideways? I mean, there's other things than salmon that are important. Or it could be birds on the beach. I don't know what else NOAA is working on.
Yeah, I think there was a joke that I made a couple of times because we have a team that's about to come up soon that did crab research. And once we saw their presentation, I was like, so we're gonna add that to this database. So I think there's definitely opportunities for sure.
Cool.
Okay, that's all the time we have for questions. Thank you. Okay, keeping in the theme with environment, we're going to see our next talk from the Washington Department of Fish and Wildlife, so let's welcome them.
Hello and good afternoon. Welcome to our presentation here at Team 25 MSDS 25.9, and our project is sponsored by Washington Department of Fish and Wildlife, and we're going to be evaluating the environmental impacts on the Dungeness crab population in the Puget Sound area.
Is voting for the project. I'm Kedarnath.
Yeah. I'm Zara.
Hi, I'm Umar.
The Department of Fish and Wildlife is a state agency that protects and manages fish, wildlife, and natural habitats across Washington. They protect nature while also allow people to do fishing and hunting. They do this by setting rules and make sure the environment is used responsibly. They also work with local communities to make sure the environment is being healthy.
So for our project, our goal is to focus on how dissolved oxygen and temperature affects crab shell condition. And understanding crab shell condition is really crucial to our project. It is an indicator of crab health. It's an indicator of multi-cycles, and it also helps you understand how the population changes. And with that goal in mind, we assess environmental factors, we identify any spatial or temporal trends, and we build predictive models in order to identify what crab shell condition exists at what waters. All of this is really crucial as it informs sustainable fishery management. So approaching this project, firstly, our main goal was to create a working consolidated data set. That means combining environmental data with crab data. Secondly, we included environmental data and crab data, identify different trends, and that allows us to kind of form our foundational hypothesis on what potentially drives crab shell condition. So whether it is region, or if it's water depth, or if it's season. Then we built predictive models. We tried a couple of different ones, and then ultimately all of this is pushed into an interactive dashboard that is going to be used internally by ourselves.
So here's an overview of the data which we were working with. So WDFW collects the data through seasonal crab surveys. At the core, we have a crab data. We collect the location, capture conditions classified as soft, medium, and hard. The sex, the crab type, the depth again categorizes medium, shallow, and deep, and the set full time and the full time. In parallel, we also collect the environmental data, particularly dissolved oxygen and temperature. All of the data is timestamped. Both of these data sets are important to understand the relationship between them and how it affects the caption condition. So here you can see on the map all the 27 stations where the pods are deployed to collect the data from. And from the bar graph, we can see that most of our data is skewed towards the hard caption condition and mostly the male hard shell category.
Now let's take a look at how the temperature is due to temperature caption condition. The heat map on the left side, we can see that the captions are distributed across the different changing at different temperature ranges. And the thick square, blue square represents the highest crab counter in the data. And it was found at the partial category at 9 to 12 degrees Celsius. On the right, and the box plot on the right side, here the temperature is distributed by shell type. And we can see both the hard and medium have the same temperature range, which is at 8. So it is at 8 degrees Celsius. And now let's look at how the dissolved oxygen is present. Dissolved oxygen affect the shell condition. Now, in the heat map, we can see that the highest number of crabs are found at 6 to 9 degrees milligrams per liter of dissolved oxygen in the water. On the box plot, we can see medium and hard have the both same range of dissolved oxygen levels, which is 6 to 8 milligrams per liter. While on the other hand, soft shell are tended to stay on the higher oxygen levels, which is at 8 milligrams per liter.
So here is a comparison of the environmental factor. So as from this graph, we can see the dissolved oxygen and the temperature over the period of 2 years. It is important to understand the relationship between them. So as from here, we can see like when during the summer as the temperature rises, the levels of dissolved oxygen decrease. So this is an important relationship to understand the seasonal patterns and how it might affect the cell condition and the crabbing.
So let's talk about modeling. In order to predict probabilities of what crab shell condition shows up when, we tried a couple of different models. So firstly, we started off with a multinomial logistic regression. This yielded really, really low accuracy, which is understandable. It assumes a linear relationship between our outcomes and our predictors, not suitable for our project. We moved on to a GAN model, or a generalized additive model. Again, this allows for a little bit of nonlinearity in the data, but it still yielded really, really low accuracy. And therefore, we as a team has decided on a random forest. It is appropriate for the context of project because it allows for nonlinearity in the data. It allows for interactions between variables. It yielded a pretty good accuracy of 78%. Might not sound super high, but for ecological data, this is the appropriate kind of percentage.
So we initially saw that our data is skewed towards the hard shell condition, and only about 88% of our data is a hard shell condition, and only about 11% of the data is the soft shell and the medium shell condition combined. And since when they're sampling the crab shells, by looking, it's relatively hard to distinguish between the two categories of soft and medium, so it may make more sense to us to categorize those two categories together and basically look at it as a binary classification problem of a hard shell versus not hard shell. But we still have a major class imbalance to tackle because the hard shell has the majority of the data. And therefore, we applied multiple techniques and we ultimately chose a random undersampling with our random forest model, and therefore to evaluate, because of this technique, the model is able to give equal attention to both the common class and the minor class. And by evaluating the model, And when we were evaluating the model, aside from looking into the accuracies for the test and also the train, we also looked at the two graphs behind me, which is a learning curve, which the learning curve essentially looks into see how the model is behaving as you're feeding it more data. And the two lines in the learning curve graphs represent how the model is improving on the training set and how the model is improving on an unseen test set. With the lines being consistent and close to one another, we can indicate that the model is able to generalize well to new situations, and it's just not memorizing patterns from the training set. And one other factor that we looked into to evaluate our model is the RC curve. In the RC curve, we're basically trying to see if the model is able to distinguish between the two categories well or no. And so in that graph, you're looking into a score called the AUC score. And for reference, the perfect AUC score is 100% or 1.0. And over here, we have a AUC score of 85%, which shows that the model is reliably able to distinguish between the two categories of hard and non-hard shell conditions.
This chart shows the features that the model rely on predicting whether the graph has a partial or not. In that, we have a biological and biological sampling and geographical features implementing the most. And in that, we can see the temperature and dissolved oxygen also plays top features, which answers the Washington Department Fish and Wildlife question. Yes, these environmental factors do place conditions to affect the caption.
So over here, we want to look at how environmental factors are actually driving the prediction of the model. Now we need to keep in mind that this model is designed to classify the crabs as either hard shell or soft or medium shell, hard shell or soft/medium shell. And so basically, when the predicted chance of a hard shell goes down, the model increases the likelihood of soft or medium shell, but only based on what it has already seen in the data. And so when we're looking at the temperature graph specifically, we can see that as temperature is rising, there's a less likelihood to see a hard shell condition. And as dissolved oxygen is rising, we see rather fluctuations into the likelihood of seeing hard shell conditions. And by looking at the depth, we can see that hard shell conditions have a tendency to be in shallower to medium waters. By looking at all of these graphs, we can get to an assumption that while temperature is rising, that could be a possibility that it triggers the molting cycle of the crabs. And so they go from hard to soft to medium, and the cycle repeats.
So here we can see the dashboard which we have developed for the WDFW internal team. On the left side, we can see the three filters, mostly year, season, and distribution. The three key performance indicators show the total crabs, the total result, the average result oxygen, and the average temperature for the selected year and the season. On the map, we can see the different stations, and when we click on each of the stations, we can see more information about that particular station. Below is the cell condition to explore more biological factors of that particular station and the environmental factors at that particular station. Now we can see the working of the track. So as you can see here, I've selected the year 2023. We can select multiple years like for which the data is available. The seasons are categorized into two categories and the station. So here the three key performance indicators are just showing the values for the year 2023 and the season, selected season. When we click on each of the different stations, we can see more in detail information about that particular station, the average temperature and the dissolved oxygen, plus the number of crabs divided into categorized into male and female. Below is the cell condition category, which gives more in-depth idea, and the environmental factor.
And so we have come to a few key findings, and that ties to future scope.
So firstly, the first thing to take away is warmer temperatures is associated with decreased presence of hard-shell crabs. A justification for this is because warmer water encourages the molting cycle. The molting cycle is when a crab goes from soft shell to medium shell to hard shell and then back to soft shell again, and the cycle continues, which leads to a temporary decrease in hard shell presence. And because dissolved oxygen and water temperature are very intimately linked, we also see in higher dissolved oxygen areas, there is an increase in hard shell crab condition presence. Environmental data such as dissolved oxygen and temperature are tied to depth. So as you're near to the surface of the water, you have a higher temperature holds less oxygen, and if you see a decrease presence of hard shell crabs, this changes as you move towards medium depth water. One of the things that we wanted to highlight is for future sampling. We are looking to incorporate a unique sensor ID in order to more easily connect environmental data with crab data, hopefully in the future that can streamline that process when we're doing pre-processing on data. Additionally, this data is very heavily skewed towards hard shell crabs, just the way that deployments are set up. And so if we want a true understanding of Dungeness crab population in the Puget Sound, that means soft shell crabs and medium shell crabs. Not only do we need to sample more within the time range that we already have, looking at sampling at different seasons as well would allow us a lot more insights to the population. And finally, with the dashboard that we've showed you earlier is for internal use only. Hopefully, we can incorporate more features, more data points, so that it's easier for somebody who's external and have no technical understanding of crabs. They can also use it and play around with it as well.
Now, I would like to take a moment to acknowledge our faculty advisor, PACCAR, and the caption coordinator, Dr. Ariana Penderley, and the Washington Department of Fish and Wildlife team, Caitlin and Corey especially, for their support throughout the project and the project center for bringing this project to us. And thank you, and the floor is open for questions.
So that, right, so as the water gets deeper, the water gets colder, and as the water gets deeper and colder, it holds more oxygen. So do you need to worry about any collinearity in your features as you're sort of doing this random forest model?
I'm sorry, can you repeat your question one more time? Sorry.
Yeah, so you have depth and temperature and oxygen, and it seemed like they all kind of played together. That as you go deeper, the water gets colder and holds more oxygen. So do you need to worry about those three features being correlated together when you're training your random forest?
So the highest correlation that we found in our model that caused a data leakage was actually a carcass width, which is the size of the crab. And with these three key variables, we didn't find any abnormalities that would be a red flag for us to see, okay, this is not working out and we need to exclude some of the variables, because we did play around with it. We gave categorical variables for the depth, and we also gave numerical variables for the depth. And so we didn't show any red flags as to the model is overfitting or there could be a possibility of data leakage.
Yeah, great job. Question on the unique identifier. I like that concept. Is that to help you locate it, or to a, like a GPS type tag, and or the depth, I guess, is the if it's moved on the seabed at all, or is it to help you associate the data, which traps are working better?
Yeah, that's a really good question. So currently the data that was given to us, because of the way the sensors are picking up the locations, we don't exactly have the exact location of the sensors are put. They take a signal of the ships that is deploying the sensor. And so we have like a start and an end point for the location. And therefore we had to look into see which of these sensors are located in which pods. and get that unique ID for that pot and allocate it to the crab data and basically see at what date, at what time was this pot deployed so that we could allocate those values for the other pods that are within that range as well. Because they're sending pods in 3 different depths and in each different depth, they're sending 5 pods, but they only put sensors in a couple of them, not all pods.
Thank you.
Yes.
I noticed you added seasonality as a filter for your channel. So, how much does it seasonality affect the crab share? Like, what we are finding?
So at first, we didn't have the variable of season. The variable of season was created based on the times of the years that they have, the year that they have sampled. And we wanted to look into see if the seasonality variable does have an influence. And I think when you look at the feature importance plot of the graph, you can look it up. In the feature importance, we do see that the variable spring or / summer does have a potential indicator to in our model.
Okay, I think that's all the time we have.
Yes. And who's going to? Yes. Then.
It's 15, so welcome back to our final session of the MSDS talks. This session is going to have our largest corporate sponsors, so we're going to hear first a talk from Amazon and also PACCAR and Costco. So let's welcome our Amazon team.
Hello everyone, we are team 25.1 and our project is the climate pledge carbon measurement, which is sponsored by Amazon. And meet our team. This is us with our faculty advisor and our project liaison. And I'm Dinesh.
I am Kip.
I'm Arushi.
Unfortunately, Dharma is not here for the presentation due to some health reasons. This is all began in 2019, where Amazon co-founded the climate pledge, which is a bold commitment to reach net zero carbon emission by 2040. For this important initiative, 561 companies are committed to reach the goal. And these organizations had a bold vision, but tracking emission progress, very complex than they thought. And our mission is to make these emission data clean, consistent, and actionable. Let's see, how do we offset the carbon?
Let's understand the basic first. So, according to the study done by MIT Climate, we need 2.2 trees working for their entire lifetime just to offset 1 metric ton of carbon emissions. So in our data, we have a particular organization which has 72 million metric tons over 4 years, just from one organization. So for that, we need a forest roughly area size of Los Angeles County. So imagine what would happen if we include all the companies across the globe. So we need a forest of countries, right? So that's practically impossible. So that's where our project starts. And let's understand further in further slides why this project matters and
why this project matters. This project helps organizations to see the progress and they can track where they were on the path of net zero goal. And this project helps for using better future forecasting and future trends. These organizations can plan better and they can do some smarter decisions. With that smarter decisions, they can stay on track for the future years. And let's see the scope classification of carbon emission under climate change. First, carbon emissions are divided into three scopes: scope 1, 2, and 3 emissions. Scope 1 is a direct emission, which comes from the company operation itself. And scope 2 is an indirect emission, where it's furtherly categorized into two emissions: location-based and market-based. Location-based is reported by the company Energy Grid, which supplies energy for in the industries in the region, and where on the other hand, market-based emission, where these emissions are reported by the company itself directly, and these organizations have a chance to choose the cleaner energy, then they can go greener than the location-based. And the last one is scope 3 emission. This is also an indirect emission, which comes from the supply chain. This emission is one of the toughest and hardest emission to calculate or report. That's why we are in this project we are dealing with only scope 1 and 2 emissions. Let's see what are the challenges facing by these organizations. Mainly, why do they face this emission tracking? Their progress is so difficult. As I mentioned before, emission data is so complex because different industries emit different kind of emissions, and they'll report in different methods and different timelines. The main challenge was there were no standardized and structured system for them to calculate these emission trends or to calculate their to see the progress. And for these challenges, we approach in these three main elements. We have data. We are collecting the data from. We had data from 2019 to 2022. With that raw data, we are taking some best features and we are cleaning for the better insights. With that cleaner data, we are forecasting our emissions until 2040. Let's see how we did it.
As now we have the cleaned and organized data, we move into the analytical phase. And now we start examining scope 1 emissions that are coming directly from companies' operation. Now, we began understanding how to do scope 1 emission by industry from 2019 to 2022. As you can see from the graph, transportation services dominate the emission sector over 169 million metric ton of carbon dioxide, surpassing far other sectors, followed by services at around 44 million metric tons. Next is materials and manufacturing. And interestingly, traditional heavy emitters like fossil fuels are at mid-timers. And whereas we talk about other sectors like health, retail, infrastructure, they show minimal to scope 1 emission. Next, we see, after analyzing the scope 1 emission industry-wise, we started examining how external factors like income affect scope 1 emissions. For that, in the graph, green line represents the scope 1 emission and red line represents the income. We have standardized both variables to show how they move relative to each other over time. As we can see from the graph that there is a dip in both income and scope 1 emission in 2020. That's due to the pandemic affecting the business activity. After that, we see that in 2021, both are increasing, that's income as well as the scope 1. But when we go around 2022, we observe that income keeps on increasing, but scope 1 decreases. That indicates that companies are growing continuously, but at the same time, they are keeping in mind about the scope 1 emission. They are on the track of reducing their emissions. To predict future emissions, we tested 3 different models. First one was Holt's linear trend model. Second one was K-means clustering, and third was random forest regression. Holt's linear trend model is basically a model that's used to identify the long trend, but it comes with a disadvantage. that it does not take into consideration the external factors. For that, we applied the K-mean clustering. K-mean clustering method was being applied to find out the clustering among the companies, like which sector or which industry are the heavy emitters. Although that's not a forecast model. So we moved to another model, that's the random forest regressive model. It excels at prediction because it considers both categorical as well as the numerical features into consideration. In random forest regressive model, we conducted that model in two phases, that is phase 1 and phase 2. In phase 1, we utilized the data from 2019 to 2021 and we predicted the data for 2022 because we were having just 4 years of data. And in phase 2, we used the same model but with advanced features, we included 2022 in that too, and we predicted about 2040. Now, in the graph, you see we have both historical as well as the forecast data for scope 1 emission from 2019 through 2040. In the graph, if you see over here, the green line that represents the actual scope 1 emission beyond 2022, that's the red line, it represents the forecast to 2040. Now, in the graph, we see that from 2022 to 2023, we see a major dip. And the major dip is because many companies, they have joined the climate pledge and they have become more aware about the reduction of the carbon emission. And then we see that until 2030, they continuously decreasing. But after that, 2030 to 2040, we see there's certain rise. So that indicates that companies need to continuously innovate technologies so that they should reduce the carbon emission on a long basis. To understand the impact and to actionable insight, we developed the interactive dashboard to help our stakeholders to monitor the progress, to find out the insights, as well as to make informed decisions to reach the net zero goal. We developed the interactive dashboard. Now we will start examining the scope 2 emission.
Coming to scope 2 emissions, as we already discussed, scope 2 is completely indirect emissions, and scope 2 is also furtherly classified into two, market-based and location-based. So basically, location-based doesn't have any option to choose. There is no option for the companies to go with. For the market-based, yes, there are options like go with renewable resources such as buying solar energy, buying electricity from clean energy stack, so that they have options to reduce their emissions. So let's see how we began our analysis on scope 2 emissions. So firstly, we analyze the emissions of both market-based and location-based over the industries. So on the part, so we came to know that services industry is at the top in both market-based and location-based, followed by materials and manufacturing. But here from this graph, we need to know two things. The main first thing is the difference in the number of emissions in both of the graphs. So when we select service industry, here it's almost reaching 52 million metric tons when it comes to location-based. But when it comes to market-based, it's almost half. So there is 50% dip. So here, the second point is, this number clearly says that market-based is the best option to go with for the companies over the location-based. So in the next graph, we thought of seeing how the scope 2 emissions are related to the income. So here, in the market-based, you can see that income and the emissions are completely opposite when it comes to location and market-based. In the market-based, it is completely inversely proportional. As the income, the red line income rises, the market-based green line reduces. It's because they have resources, they have economic development, and they are trying to spend their more money on reducing their carbon emissions as they are signed to our receiving the climate pledge, right? So when it comes to location-based, no. Even they wanted to decrease their emissions when it comes to location-based scope 2 emissions. They can't because they don't have any options to go with. So what we did, so we tried to see we tried to see the forecasted data from 3 models, and we tested all these 3 models, which is linear regression, extreme gradient boosting, and random forest regression. So out of these 3, random forest turned out to be the best performer. So we chose that to predict the next years till 2040. So when it comes to location based, here we can see even in the beginning of 4 years, which has the green color, the 4 data points that we are using and that we currently have. So there is up and rise because of the COVID pandemic and everything. But after 2022, there is a dip. It's because of the model predicting maybe the income is rising and maybe the location based companies are moving to the market based on all of the data that they have. So that's why they have lower emissions continuously. But the main thing that is we need to focus is basically they are gradually decreasing. There is no way that they are increasing beyond the point of current that we have. There is increasing, but it's not zero, but still it's good. That's a good point to note. But when it comes to market base, it's been decreasing since the day one. From the 2019, it's been decreasing as the green line shows. But the main difference from the forecasted data from market base and location based, the maximum point that we are reaching of emissions in 2040 is already reached at 2031 itself. So basically, we are 9 years ahead of time when it comes to market base. So even the second graphs, even the forecasted data suggests that market based is the best option to go with for all the companies across the globe. So here's an interactive dashboard for scope 2, which is similar to scope 1. And but the thing is, we have two type of emissions in scope 2. So that's why it might look complex, but it is easily understandable, and we have some user interactions as well.
For the key finding during the project, we found out certain important concept things. Like forecast to 2040, it basically indicates that companies are on track, as well as the signatories, the companies that have joined the climate pledge. They have shown the emission trend consistently, as well as during the analysis part, we found out that there is a strong link between income and emission. That there is a positive correlation, they are positively related to each other. Next, we move on to the path.
So, to a conclusion, our analysis and development of model is not only focusing on the visualization, but also helping Amazon and its partners to make smart decisions and data-driven decisions to make their net zero goal and to reach the net zero goal faster, way faster. And this project is not only just the visualizations, but it is also a path for entire world to join in the climate pledge and reach the net zero goal so that we have a good climate and green economy. Let's understand the conclusion.
I would like to conclude this by saying we have three main goals and three main deliverables. The first thing is we turn the scattered data into structured format for the better insights. With that better insights, our models are predicting the future emission trends for where the organizations have chance to go greener. And we build interactive dashboards for easier to understand the upcoming trends so that they can stay ahead for the future years. And then they can reach the net zero goal. Thank you. I would like to acknowledge all the support and help of our project liaison Benjamin Jessup and faculty advisors Dr. Elias Zhang and Dr. Ariana Mendevel. And I would like to special thank for the project center for bringing up this to us and connecting with us. Thank you. And the
With your random forest models, either the one in type 1 or type 2, can you say more about what were your feature vectors that you were using to predict? Like, were you doing one step ahead forecasting, and then like what were the features that you were using for that model?
So for random forest regression model, we basically use both the categorical as well as the numerical features. For categorical features, we use primary sector, primary industry, size, as well as the area. And for numerical features, we use scope 1 emission for 2019, 2020, 2021, and income feature, as well as we found out the scope intensity, that's basically the scope emission over income. So these were the features that we used in the random forest regressor, and it basically was being conducted in two phases, that is phase 1 and phase 2, because we were having just 4 years of data. So what we did was, in the phase 1, we trained our model from 2019 to 2021 on basis of that data. and we predicted the 2022 data. On that basis, we found out which model is accurate. And we got the accuracy of approximately 90.57%. And then after that, in phase 2, we used the same model, and then we predicted for 2020. That was the process that we did for the rainforest replacement model.
How much data did you have for training?
For data, we there are 561 signatories till date that have signed the climate pledge. But after cleaning the data, we were just left with 69 companies because many companies they are not reporting, and for the 69 companies also we did the manual search. We went to each and every company website, searched the sustainability report, and from that we found out the emission data. Because the data that we got was having missing values, and if we would we thought of using the imputation, but that could have introduced the biasness, because this is a carbon emission and we don't want to introduce any biasness in our project, as well as our sponsor also wanted that there should be no biasness in the project. So for that, we went to each and every company website and got the data. So for the data point, we were having 69 companies.
I know you touched upon this in the previous question, but so you explained you cleaned the data and you chose important features. So can you explain the process of what features did you choose and how did you choose it? Did you rainforest or?
So the first model that we considered was the Holt's linear model. Now, when we consider the Holt's linear model, it's basically a long-term trend model. It's just use the scope 1 emission. That means it will use the past emission to predict the future emission. But at the same time, we realize that emissions they are dependent, like on the company size, the number of employees the company is having, as well as the income. So for that, we were not having the income data as well as we were not having the size of the company. So for that also, we not manually extracted, we use the APIs, we gone to the financial modeling website, and from that we scrape the data for income as well as for the size of the employees, and then we merge that data into R, and after that we applied the random forest regression model because it was a consideration Holt's linear model was just considering the past emission data. It was not considering any external factor. But during our analysis, after finding out the income data and the size of the employees, and when we did the exploratory data analysis, we found out there is a relation, and that is also a positive relation. So that's why we went to the random forest regression model, because it considered both as categorical as well as the numerical features into consideration. I guess. Did I answer your question? Any other question, please?
We don't have any more time for questions. So let's take our speakers. So
Welcome everyone. Our team is excited to present our project, which is Voice of Market, Unlocking Market Insights from Social Media. We are part of team MSDS 25.4. In our team, there is Mustafa, Rishikesh, myself, Lakshan, Priyal, and Tejasvi. So Costco Wholesale is one of the largest and most successful retailers in the world, known for its membership-based model that drives customer loyalty as well as operational efficiency. As of 2024, Costco has served over 137 million members, making it the third largest retailer in the world. Costco has earned its reputation by focusing on delivering high quality products at very competitive pricing, hence earns the trust of its customer. And it operates on the business strategy of low margin and high volume, ensuring affordability without compromising on quality.
In today's generation, everybody uses social media platforms to share their thoughts in form of comments. But these comments are very unstructured and hard to use. Traditional methods like e-commerce reviews or surveys are pretty slow and outdated, lack real-time insight. For example, if Costco runs a survey of a new launched product, it might take up to weeks to gather the data and analyze it. This will only increase delayed responses and lost trust of customers. But why this matters for Costco? Costco is a member-centric company and wants to know every member's voice to improve customer satisfaction. If we know what customers really want, then we can, if we know what customers really want, then Costco can make smarter and faster decisions. That means catching issues early and fixing them to protect the brand.
Here's a high-level view of how we structured our entire project life cycle. We started by cleaning and organizing customer feedback from various online platforms. And then we identified the key trends, patterns, and sentiments. And then we also packaged all these insights into easy-to-use tools for Costco decision makers. And all of this was done within 18 weeks. We also made sure that each phase was carefully paged to ensure quality, relevance, and business impact.
This was the most important step for our project, that was data collection. So initially we did not have any data due to Costco's private policy. So we had to scrape from multiple social media platforms like Instagram, Reddit, X, Costco's official website, as well as Site Travel, which is only a review site. So we used Beautiful Soup and Scrapey to scrape the data as well as public APIs which were available. Let's see an example how we scrape the data. So we can see curry and salted mixed nut, that's the post title. We scraped first, then the whole comment. What's the timestamp, how many likes it got, how many comments and ratings. But while doing this, we faced multiple challenges like platform restriction, limitations with data fetch rate, as well as inconsistent data formats like multi-language data. But despite of all these challenges, we were successfully able to scrape around 400,000 plus rows of data. But now the question arises how we can unlock the insights using the social media comments. Let's understand with an example.
Let me ask you all, when was the last time you wrote a product review? Did it actually help someone make a decision or was it just a quick reaction? That's exactly what businesses like Costco deals with every day, with tons of feedback coming in, but not all of it is helpful. Let's take a look at this slide. On the right, we have got some short, vague reviews, maybe emojis or generic one-liners. They are positive, sure, but they don't tell us what actually worked or what needs to be improved. On the left, you will see something different. Those reviews got into detail, like how scrubs have been used, what customers like, and even the small issues that might have otherwise missed. Now, imagine yourself on Costco's marketing team, and you are dealing with tons of feedback coming like this. So, which type of reviews you will give you something you can actually act on? Exactly, the ones with the specific information. This isn't just about cleaning products, it applies to every category, whether it's electronics, groceries, or home appliances. And without a proper structure, this flood of feedback quickly becomes noise. But when the feedbacks are clear and consistent, they become a powerful tool for real decision making. So how do we separate the helpful reviews from the vague ones at scale? Let's take a closer look at it in our next slides.
Our pre-processing had 4 major steps. The first step is text cleaning and spell correction.
Our data had a lot of unnecessary characters which were eliminated in this step, and also there were a lot of misspelled words which were corrected. So we can take an example review which states loving this jacket. When this review goes through the step, we can see the bases have been removed and also the word jacket has been corrected. The next step is stopword removal. Our data had a lot of commonly occurring words which need to be eliminated, and this was done in this step. So the output of the last step is fed as input to this step, and we can see the word this has been eliminated. The next step is lemmatization. So in this step, many words in our data were reduced to the base form. We can see the word loving has been reduced to the word love. And the last step is tokenization. Here the text was split into number of smaller units called tokens, and we can see a list of words as a result of this last step. So coming to the methodology. In the topic modeling, initially we used the latent research and allocation method to map the posts to specific topics. But in order to enhance the results, we later used the sentence transformers for direct mapping between posts and predefined categories. Next, coming to the core part of our project, which is the sentimental analysis. Here we classify the reviews as positive, negative, and neutral. Here we use the machine learning model VERA for short and informal reviews, such as that on Reddit, Instagram, and SiteJabber. And for long and emoji-rich text, we use deep learning models such as BERT and Cardiff NLP for platforms such as Costco.com and Instagram. For increasing the accuracy of the outputs, we use the N7 methods for better accuracy.
Now that we've extracted meaningful insights from various customer feedback, our next goal was to make these insights accessible, actionable, and ethical. So first we started by using two summarization techniques, extractive summarization, which means we summarize by identifying the important sentences from the original text. And then there's abstractive summarization, which means you summarize the whole text in your own words without losing its original meaning. And then we have two key delivery formats. So one is a Power BI dashboard, which will show the real-time view of the dashboards and different platforms. And then we have an AI-powered chatbot, which quickly summarizes customer comments within seconds and also helps non-technical users get answers fast. We also made sure that every customer's data was anonymized and to ensure data privacy. So this slide marks the turning point from process to performance. We organized around 400K customer comments, identified platform-specific patterns, and gave actionable findings. So what's unique is that these insights are not just they just don't reflect the ratings, but also help us understand what's the tone and sentiment behind customers' voice.
Now let me walk you through the overview section of our dashboard, built to show customer sentiments and product conversation across time and platforms. At the top right, we have added filters that will help users select a particular time period and platform, making it easier to tailor the view according to the focused use case. After that, we have added a navigation panel that will help users navigate across all insights which we have gathered from all the social medias which we have used in our analysis. There is also an integrated button for our AI chatbot. The four blue tiles here gives us a total engagement about the number of likes, comments, and posts across all channels, giving us an overall quick snapshot about what's happening at scale. Moving on, we have the annual sentiment and trend chart that shows how feedbacks have changed from 2014 to 2025. From the graph, we can clearly see that both engagement and positive sentiments have increased, especially from 2020 onwards. The negative comments have also increased, but the widening gap between the positive sentiments and negative sentiments shows that people are talking more positively year after year. Next, we have the horizontal bar chart that shows most discussed product categories drilled down by source. From the graph, it is clear that appliances have gained a dominant conversations on Costco's official site, while groceries and household appliances have gained more importance on Instagram and Reddit. This helps teams not only to understand not only what customers care about, but where those conversations are happening. Overall, this dashboard brings together real-time sentiment trends, product priorities, and platform level engagement all in one unified view.
Now that we've looked at the overview page of our dashboard, now let's look at a platform-specific page, Reddit. So Reddit offers some of the most honest, detailed, and constructive feedback. It's like a goldmine for understanding pain points, praise, and different sentiments of Costco customers about their experiences. Now let me walk you through each plot. First we have a sentiment tree map which shows the most discussed product categories, and the darker shade indicates the most talked topic, which is home and kitchen. And then we have a word cloud which shows the most frequent words, and we can see the bigger the word is, that is how much it is repeated. So here we have buy, bottle, good, etc. And then we have a product category sentiment map which shows which product has the highest number of positive reviews or negative reviews or neutral reviews. We can see that home and kitchen has the highest number of positive and lowest number of negative reviews. And then we have a comment volume sentiment time frame, which shows that April 2024 had a dip, so which might make sense because like through December to March there are a lot of sales happening, and that's when suddenly people stop buying stuff. Not everyone, but most of them. So overall, this helps us drill down into not just what people are saying, but how they're saying it and what Costco teams might want to prioritize.
This graph shows the sentiment trends for product reviews across Costco's official website. Here we can see the categories such as appliances, furniture, and TVs have a high amount of reviews. Over here, when we select a category, then a number of products under that category are listed further. And when a particular product is selected, the sentiment trends across that product are listed further. So for example, when we select the TVs category, we can, after that, when we select the first product, you can see majority of the reviews for this product are positive. Next, coming to the final insights. So for the Costco's official website, we had majority of the reviews as positive. These were for big ticket items such as appliances, furniture, and TVs. For Instagram, there was positivity for day-to-day groceries and essentials, and also for promotions. For the platform Reddit, the majority of the reviews are positive, and these are honest reviews for topics such as pricing comparisons and in-store experiences. For Twitter, we can see the percentage of positive and neutral reviews is the same. There were spikes in the sentiment trends across several months for this platform. And lastly, for SiteJabber, some amount of reviews were negative, and these were really helpful to identify the potential bottlenecks. And we also got a large amount of negative reviews for categories like appliances, furniture, and TVs. But we have to keep in mind that the amount of positive reviews were more as compared to negative for these categories. And with these actionable insights, Costco can increase the customer growth for trending products, and also it can focus on products which are underperforming.
So now let's just walk through a short demo of Costco Review Assistant chatbot. So here on the main screen, you see the front end that is designed using Streamlit, and it serves as a user-friendly interface where the users can ask any kind of question regarding the Costco's products, customer sentiments, or the emerging trends. The chatbot is powered by Google Gemini 1.5 Pro model and the sentiment data from all over the social media. So right now we'll focus on the user input section area where the user can ask any question using the natural language queries like what are the sentiments around the pet products, or summarize the reviews around the Costco's membership services. So the chatbot will quickly analyze the input and will provide us with a response that is both qualitative as well as quantitative. So it will search across the sentiment data that we have. So now moving on to the answer section, the chatbot not only provides us with a direct response but also gives us a detailed response like how many comments were there, the distribution of the comments, and the key trends or the concerns. Now, next we have also added a new chat feature where the user can switch to different topics without the results of the previous conversation hampering the new one. So, if you look at the screen, the user will ask a new question like what do people think about Costco snacks? So the chatbot will again analyze it and provide us with a detailed response. So over here, we have additionally added, if the user likes the response, they can click on the thumbs up button, and if the user thinks the response is irrelevant, they can click on the thumbs down button. So this kind of acts like a real-time feedback mechanism for the chatbot responses. So this feedback loop not only allows the chatbot to assist the users, but also help us to gather more important information for future announcements.
Finally, to sum up our work, we have gathered and analyzed over 400,000 plus comments. We have created an automated pipeline that can track sentiments. We have also created a chatbot that can give real-time and quantitative results. The system is scalable for Costco so that they know what customers' opinions are. Looking ahead, we also want to add real-time alerts as well as voice and audio feedback.
Before we wrap up, we would like to take a moment to thank everyone who has supported and guided us throughout this entire journey. And to the audience, thank you for your time and patience. It means a lot to us. Thank you.
Yeah, I'm curious how, for example, if you're presenting these insights to like a product manager, how might you account for maybe like survivorship bias in the data? Because this is just data from customer reviews. So a customer is gonna leave a review if they really like the product or if they really dislike the product. But not much data is going, they likely won't leave a review or make any comments at all if they just thought the product was okay. Yeah, how might someone account for that?
I mean, that's the point of collecting all this social media feedback, right? Because some people are just like writing negative reviews about the products, or some people really like to take effort and put their time to add a review about a particular product. So that's why gathering the data from all over the social media, like Reddit, Instagram, everything. But I don't think anyone can take responsibility if that data is correct or not.
Also, like if someone likes the product, but we're not trying to help that, like it's already helpful and someone is using the product, we're just trying to help if someone is not liking the product and we want to help with that, right? So I think it's still good if they are not leaving a comment even if they like.
I can add to that. I'm with Costco. So on top of this, we can tie back those results with our sales data. So we do have our internal data, but we do not give access to the members because of privacy reasons. So we can take those feedbacks. We can do a secondary round of check of sales going up or down. Based on that, we can take the additional steps.
Yeah, and I would like to add, coming to, giving assurance for the results. So we have done a lot of grouping of the data based on topics and categories. So altogether, we would get sentiment insights for a particular category or a topic, and that is a collective, result of majority of data. So the output should be, satisfiable.
Unfortunately, that's all the time we have for questions. So let's thank our speakers and ask if you have questions.
Good afternoon, everyone. Good afternoon, everyone. We are Team PACCAR and we are here to present our capstone project, which is outside sales staff calculator. So meet our team. I'm Nithi.
I'm David.
I'm Divishri. Unfortunately, Oliver will not be joining us today for the presentation, but we truly appreciate his contribution throughout the project. So, PACCAR is a global leader in truck manufacturing. They are known for big brands like Kenworth, Peterbilt, and DAF. With over a century of innovations, the company has built a reputation in designing and manufacturing high-quality trucks. PACCAR follows a dealer-driven model wherein they do not sell their truck and truck parts directly to the customers, but instead they do it via dealerships. So, dealership plays a crucial role in connecting with customers and driving business sales. PACCAR is always focused on innovation and is looking for market growth. One key area of improvement for them is to find the optimal number of staffing required at each dealership location. Let us understand our problem statement better. Imagine you are running a trucking business, but instead of you going to the dealership to buy a truck part, a salesperson visits you and helps you find the right part. But what if there are not enough salespeople available at the dealership in your location? Or on the other hand, there is a dealership which has too many salespeople associated with them, but the demand is really low in that particular area. So in that case, it will only add to the operational cost of the dealership without adding any potential revenue. This will have a great impact on the business because a dealership is always at a risk of being either understaffed or overstaffed. In both the scenarios, it will not only lose the revenue but will also fail to support the customers. Our project aims to deliver a calculator app which can be utilized by the dealerships to find the optimal number of outside sales staff required at their location to generate the desired revenue. To understand our problem statement better and to derive a solution, we have considered these factors like what is the market demand or market potential for particular truck parts, who are our customers and what parts do they need to keep their business running. Since our salesperson is traveling from dealership to their location, what is the time that they are taking and how long they are traveling. And we have utilized three major categories of data throughout this project, which is trucks, parts, and dealerships. The trucks data contain the vehicle identification numbers. It has the company registrations, which is about 280 millions of records, the locations, service history, and mileage history. The parts data has about 400 different categories parts data, the price of manufacturing that part, the cost of selling that part, the sales history, the replacement mileage. The dealership data has about 768 dealership details along with their location, part purchase, and their staffing details. To understand the market structure, the salary structure and staffing structure outside, we did utilize some external data, which is US Bureau of Labor Statistics and staff salaries.
In order to maintain a structured workflow, we have divided our project into three major milestones. Milestone 1 being the market potential model, where we develop market potential model which is helpful for estimating the market demand of each dealership. Coming to the milestone 2, where we have applied constraint optimization process in order to estimate right and optimal number of sales staff at each dealership. Finally, we have tailored these all recommendations into our milestone 3, where we have developed an interactive web application on a single platform in order to help PACCAR dealerships to leverage these insights into their decision making. Moving forward with the milestone 1, in milestone 1, it's mostly about combining all the data sets that were given by PACCAR and cleaning all the data sets. So once we have cleaned this data, then we move forward with creating additional fields and populating different missing values such as average replacement miles per part or the truck location and many more. So once these all additional fields and missing values are being populated, we have then developed a series of computations to output for the overall market share of each dealership.
Now, let's talk more about feature engineering.
So in the feature engineering, we wanted to look at the parts needs, and there were many part types that we had in our data sets. So it was broken up into categories, and for those categories of parts, we took the average replacement mileage and the average price. Here we have some example parts that you might have experience replacing on your own vehicles, and we can gather some relationships into that data. So, for example, oil filters need to be replaced a lot more often than, say, transmissions or fuel pumps. However, when looking at the price, we can see that oil filters cost a lot less. And with these two pieces of information, if we get the truck mileage, we can then gather additional insights into what parts need to be replaced, when do they need to be replaced on a truck, and how much that will cost. And with that, earlier we mentioned we need to know our customers, which are our truck owners who need to purchase the parts. And so to get our potential customers, essentially the trucks, we needed to calculate the distance between the trucks and the dealerships. And we did this by using GPS coordinates, if those were available. If not, we used the truck's registered address. Now let's continue talking more about trucks. With that information, we could gather the unique list of trucks in the dealership area. But next, we needed their mileages. And to do that, we either use the actual mileage if they receive service at a PACCAR dealership. If not, then we created a process for estimating the mileage using industrial averages from a third party that works with PACCAR. Now with the mileage, we can start to get an annual maintenance cost for trucks and see how much they might spend over the year. In addition, we had makes of our trucks as well, so we could group the data. And we have an example chart of showing what makes have higher mileages. And potentially sales staff could use a report like this to target companies that are operating those higher mileage trucks that might have more service needs. So let's look at the whole picture. And so we have calculated the customers, which are the trucks in our area. We have calculated their parts needs, which is our market demand for truck parts. And now we can combine that together for all trucks in the area to get a total market potential for that region, which we'll now use in our constraint optimization process in milestone 2. So earlier we mentioned our main objective was finding the optimal number of outside sales staff. However, since the dealerships need to be successful, we wanted to focus on revenue, specifically the number of staff to reach a maximum part sale revenue in their area. With this in mind, we needed to define a function for estimating the part sales revenue for a dealership using input parameters, one being the outside sales staff number. And then in this example, we have the number of hours they are traveling to customers as the other input parameter. Next, we need to define constraints because the dealerships operate in the real world and there are limitations. Those could be items like operational costs or the number of hours an employee could work during a day or the number of trucks in that dealership's area. So with these constraints, we could implement our SciPy optimization Python library process to find the optimal number of outside sales staff at a maximum revenue point. In this example, in the main constraints we have defined here that are leading our solution are in red is the minimum amount of time employees need to spend traveling to customers. And then in blue, we have the number of customers they can visit before there's too much competition for the customers. And with those constraints, our solution in this example is a recommended number of 18 sales staff generating 41 million in revenue. So now let's look at more examples. Here we have a few extra results from dealerships. The process can do more than just recommending the number of staff to achieve a maximum value. It can be adjusted for dealerships to try to reach a market goal. So, for example, a dealership may want to increase the revenue by 10 million. This could be added to the process and it could output the number of additional staff they need to hire to reach that goal. Or if the dealership is looking at hiring 1 or 2 new staff members, they can use this process and see how much additional revenue those new staff members could generate. Now with our recommendation on the number of staff and the maximum revenue, let's move on to talk about milestone 3.
So in our milestone 3, we have laid all these recommendations into an interactive web application using streaming platform. So this is our homepage of our outside sales staff calculator. So the dealership user or the manager can just choose it from the drop-down menu to the specific dealership which they were interested in and just click on the find an optimal value. So once the option is selected, the model pulls back the market data of that dealership along with the population of trucks and as well as the parts demand of that dealership. So once this data is all collected, this data will be prepared for constraint optimization process. So once the process is done, the graph is displayed, which represents the projected sales as staffing increases. So the red and the blue line represents the distance and market constraint, and the red dot indicates the optimal sales staff at that dealership as it balances out the projected revenue based on their practical limitations. Right below the graph, we can see there's a recommended sales staff number displayed and current outside sales staff at their dealership. Along with that, we can see there's a comparison between estimated revenue and current revenue of that dealership. So these all numbers will give a big picture to the dealership manager how exactly these adjustments could impact their bottom line by doing this all. So in order to give a more flexibility to the dealership manager or user, we have developed a settings panel where the dealership manager can actually adjust a couple of values so that he can test out and experiment different scenarios based on their unique operations. So in those features, success rate would be 1 and the hours driven or the driving time that would be taken for the outside sales staff would be 1 and other thing is the visit frequency per year to the customer. So to conclude, our project will help PACCAR dealerships in order to make data-driven and decision-making help by combining the market potential modeling with the constraint optimization process and tailoring this all into interactive web application. So this tool will help PACCAR in having a smart planning and improve customer outreach and also enhancing the market share efficiently. We would like to take a moment and thank all who have helped us and guided us throughout this project.
Another kind of like a business question. So there's kind of like when it comes to suggesting more employees and suggesting lowering the amount of employees, there's kind of like I'm imagining there's kind of an asymmetry with the risk where I think it's okay if your model predicts to add more employees. It's not like that'll hurt. It might not hurt the business as much. Then maybe if your model suggests to remove employees or decreasing the amount of employees, it might that might make it the case that like that location might not be able to function might function significantly worse. Is there a did your predictions or did your models perhaps like account for this asymmetry?
Yes, like you're asking like whether the model is asking to fire someone or hire someone, right? Yeah, it is. Like the goal of the project is about the balance, increasing the market share of the dealership by having the right amount of sales staff. So we do have a couple of examples for few dealerships where it recommended to fire few people. Yeah.
overall, I think it appears that there's usually more demand, and most of the results were hiring additional staff to meet that demand. So more often than not, it looked like it was recommended hiring additional staff.
What model did you use to get the recommended value?
So we use the SciPy optimized library, and the specific algorithm we used for doing the constraint optimization process with the sequential least squares programming method.
So in your optimization model, did you consider competition from other parts providers?
So unfortunately, we did not get to that in this project. I think it's a good feature enhancement to try to get additional data about the competition and how that influences demand and impacts demand. It's sort of built into we had a value for success percentage for the sales staff. So that accounts for the competition a little bit, how successful the staff would be, but it doesn't directly account for it.
Okay, if there's no remaining questions, let's thank our speakers again. That concludes all of the presentations for project day. Now we have a reception and a poster session, so please come by and ask all of your remaining questions to all of our students, make them think about their projects more. And afterward, there will be snacks and drinks, so please stick around and be. Thanks for coming.